Good day, friends. Right now, let's try to solve this problem. A ball is thrown from the floor with a initial velocity of 10 meters per second at an angle 60 degrees to the horizontal. At a height of 3 meters, there is a perfectly elastic ceiling. Find the horizontal distance from the point of projection to the point where the ball lands on the floor after bouncing off the ceiling. Take a free fall acceleration 9.8 meters per second squared. Okay, so basically what we need to find in this problem is, as you can see here, the distance, the range from point projection to the point where the ball lands on the floor. Okay, so basically we need to find in here this length. We need to find this thing. Yeah, and what we have here in such kind of situation. So basically we have a room and a ceiling which is 3 meters in height. Okay, and when we just throw the ball after a certain time, it hits the ceiling. Yeah, and then it falls back. Okay, so what is interesting about this situation? We can just cut this in half. We can make something like this. Okay, then what we can do is just write the basic kinematic equations. Yeah, we know this formula. We can just apply one of them, I guess, which is just delta x equals v initial time plus 1 divided by 2 at squared. Okay, that's the formula that we need for now. Okay, so we can apply this formula for both situations, horizontally and vertically. For example, for right now, let's try vertical one. Yeah, so our change in distance vertically would be just, if it's just 0, it would be the entire height. So basically it would be just h minus 0. So this is just h. Okay, so our initial velocity is this one. So we have two components, which is this one and this one. And our horizontal component would be definitely v sine alpha, because it is the opposite, right? So we just know how to use this formula. So it would be just v initial sine alpha time. We don't know what time it is, but we say that it takes some time, yeah? And it takes the same amount of time to go other way, but it doesn't matter right now. Right now we just consider only the first half, only this part, okay? So it takes some time to hit the ceiling. And then, is there any acceleration? Yes, there is. And it's negative 1 divided by 2 gt squared, because our acceleration in vertical axis would be just the gravitational acceleration, right? And it's negative because it's directed downward all the time. Okay, what about the x-axis? Again, we talk only about the half of it, right? So what's interesting about this is that we can write something, yeah, we can just, as we have said before, we can divide it to two halves like this. It would be just L divided by 2, right? This is L divided by 2 because the entire range would be just L. So we can just write L divided by 2 equals our initial velocity, but the horizontal axis, it would be V cosine alpha, right? So V initial cosine alpha time, and there is no any force acting on our ball horizontally. That's why if there is no force acting horizontally, there is no acceleration, okay, horizontally, right? So this is the thing that we need, and we can write this like this. 2vi cosine alpha t, because I've just taken this 2 and moved it other side, right? Okay, so what we can do with it, yeah, we can do something like this. Let's move all of those things, this thing to another side and this thing to another side, and we will have something very interesting. It will be just 1 divided by 2 gt squared, and this thing would be minus v initial sine alpha t, and this thing would still be just plus h equals 0. Okay, what's interesting about this? We don't know what time is, right? But right now, can you see this thing? This is basic quadratic equation. So basically it's something like this: ax squared plus bx plus c equals 0. Yeah, instead of plus we have minus in here, and you can see this tendency something like this. So this a is this 1 divided by 2g, this b is this entire thing minus vi sine alpha, and this c is just h. And you know that quadratic formula, which is basically in order to find x, you just write this something like this: minus b plus minus square root b squared minus 4ac, and all divided by 2a, right? So you can do the same thing to time, and we can write it something like this: time would be equal minus b, which is negative vi, and negative to negative would be just positive. It would be vi sine alpha, and plus minus, but we can delete plus, because plus means that what it would be if it didn't hit the ceiling, right? So but our ball did hit the ceiling. That's why we can just take this plus off. Okay, so we can continue the same thing right here. So b squared would be just v initial squared sine squared alpha, and what? Minus 4, our a is 1 divided by 2g, and last thing is c, which is just height. Okay, and all this thing is divided by 2a, which is 2 multiplied 1 divided by 2g, right? So let's just cancel this out. Let's cancel this out. This would be just 2. And you can see something like this. Yeah, time equals v initial sine alpha minus the square root v initial squared sine squared alpha minus 2gh. And all this thing divided by just g. Yeah, right. Good. Okay, I like it. I like it. So what can we do about this? The thing that we can do about this is very interesting. Let's give this give this g to each one of them, right? So to this one personally, to this one personally, to this one personally, and you know that what's going to happen right now. It's something like this: v initial sine alpha divided by g, and because of its square root, when we put everything inside square root, it goes squared, right? So it's going to be something like this, all this squared. So it would be v initial squared sine squared alpha divided by g squared. This is very important. And minus 2gh, also g squared. Okay, and we can cancel this out. And what also? Okay, so can you see this thing? So this thing and this thing are very similar. This is the very same thing, but this is just the square version of this thing, right? Okay, and what can we do? We just can take the common factor. Basically, yes, we can do it. And we are going to do it. It would be something like this. Time is equal to, okay, vi sine alpha divided by g. Yeah, we take this out. This is going to be 1 minus, and square root all comes. Yeah, this thing is going to be 1 as well. Why? Because when we put this thing inside here, inside of 1, it will become this thing. When we put this thing here inside of square root, it goes squared, and that's what we have. Okay, good, good. I like it. And what also we have here, it would be minus as well, right? Because we have minus 2h divided by g. So how do we write in this situation? So we've got 2h divided by g. Well, it's the same thing as dividing, right? We are dividing all those things to vi sine alpha divided by g, and we are doing the same thing here. We're doing the same thing here. So we can just write the very same thing, yeah? And it would be just something like this: vi sine alpha divided by g. And yeah, this is in squared. Yeah, we mustn't forget about the square because it's still inside of square root. And this thing is going to cancel, and yeah, nothing else. But when we make this more beautiful, we know that g is going to go upside. Okay, so it's going to be something like this. Let me write it here. T equals v initial sine alpha divided by g. Okay, let me take it and put it somewhere here, right? And inside of 1 minus square root 1 minus 2gh. And here we have vi squared sine squared alpha. Okay, and the brackets. Yeah, we should not forget about the brackets. Okay, good. So that's the thing, what our time is. We need to make it a little bit like this, yeah? We need to highlight it. This would be the answer for our time. And we can totally apply it in here. Why not, yeah? We have this formula for distance, for the entire distance, yeah, because we are taking into account that it is just a half, and we can throw that 2 to another side, and we will have the same thing as here, and this would be the entire length. Okay, so we can put all this t, as you can see here, this time, inside of here, yeah, and this would be correct, yeah. Okay, let me write it down in here. Oh, no, let me just copy it, yeah, that would be even more appropriate. Let me just copy it and put it somewhere here. Yeah, let me copy it and put it somewhere here. Yeah, why not? Yeah, and if I put it inside, it would be just something like this. Okay, L is still there, 2vi cosine alpha, and here we have vi sine alpha divided by g, and we need to put all that thing. Let me take this thing and just paste it right here. Yeah, right. So yeah, that's the thing that we need. And as you can see here, we can see something very interesting. We can see this thing. Yeah, we can see that here is 2 cosine alpha and sine alpha. We can also see here 1 v initial, 2 v initials, which are multiplied to each other, and definitely it will be what? L equals v initial, it would be just v initial squared, and 2 sine alpha, cosine alpha. Isn't that something very familiar? Yes, of course, it is sine 2 alpha, all divided by g. And then we've got just this thing. We put it here. So basically, that would be our final answer. Yes, it's long, but the main thing, this is correct. Yeah, you can try it yourself. You can check it. You can put numbers, and you must have some answer around, if I'm not mistaken, 4.7 meters, I guess. Yeah, if you apply all those numbers, you must have that answer, 4.7 meters, around that. Yeah, yeah, that is our final answer. Yeah, in fact, it's not that hard. We just applied one formula, which is this one, and used it vertically, used it horizontally. Then we just applied basic quadratic equation. Yeah, and then we just took this long answer, but not that hard, and put it just inside of the second equation, and then we just have the entire answer. Yeah. Thank you for your attention. If you didn't understand some things, you can write me privately. That's it for right now. Thanks. Goodbye.